Okay, today we're going to look at finding the equation of a cubic function. We're going to use Mr. Autry's notes, and hopefully it'll help us to understand what's going on. This video will help. First, he makes a point right in the beginning that there's some stuff we learned in grade 11 about functions that we've got to use right here. And one of them is, if they give you a point on a graph, then that point makes the equation true. That means you've got an x and a y value that you can put into the function and then maybe solve for some other things you don't know. But you can substitute in that x and y value. And that's what we're going to use in this next example that we look at, the first one. Well, this was an exam question where they gave us a picture of a cubic function. And all they gave us was that f of x equals ax cubed plus bx squared plus cx plus d, 4 letters that we don't know, a, b, c, and d. But g of x is a line equals 6x minus 6. That must be the line. It's a linear equation. Hey, they've given us something here. When x is 0, y is minus 6. We've got the y-intercept of the line. It looks like the y-intercept of the cubic function. That means when x is 0, this d must be minus 6. We can get d without doing very much work at all. But now, there's 2 other pieces of information they're giving you on this graph that are really important, and they're called x-intercepts. Now you remember about the x-intercept form of a parabola. You can take factors like x plus 1. X plus 1 in brackets is a factor. That means y minus 1 makes the function 0. If minus 1 makes it 0, x plus 1 is a factor. And if 3 makes it 0, then x minus 3 is a factor. If it turns right on the axis here, on the x-axis, you know that it's squared. So all of a sudden, we've got all sorts of information to be able to make the graph happen. We know that it's x plus 1 times x plus 1 times x minus 3. Well, let's look down here. X plus 1 times x plus 1 times x minus 3. The only thing we don't know is a. X times x times x, that gives me the x cubed, ax cubed. But let's see here. Oh, yeah, they gave us a point. Let's look back here. They gave us a point of 0 and minus 6. That means into this new function with the in brackets here with the factors, we can put in x is 0 and y is minus 6. And that's really good because all of a sudden, 0 plus 1, 0 plus 1, see x is 0, 0 minus 3, 1 times 1 times, it's just minus 3a. Minus 3a equals minus 6 divided by negative 3. Now we've got a. Ooh, this is good because we can put the a in there. Then we just multiply it out. X plus 1 times x plus 1. We do our FOIL thing, or we know it's x squared plus 2x plus 1. Then we multiply it out carefully by x minus 3. X squared times x is x cubed. And you got minus 3x squared. You got plus 2x squared. You're going to get minus 1x squared. You can work out the x's and put them together to get minus 5x. And 1 times minus 3 is minus 3. Now multiply everything by 2. You'll get 2x cubed minus 2x squared minus 10x minus 6. And wait, we've got a, b, c, and d we knew was minus 6. So that looks super hard, but if you are able to look at the graph and see, oh, we're given the x-intercepts, we're really given factors, then using that point, writing it all out, the factors, and using that point and substituting it in, we got started and we got a. So it was a little bit tricky, but not impossible. So that's it for the first part. The next question, we're going to have to use some other aspects of cubic functions like turning points and other things, and maybe a simultaneous equation. We'll see you then.